Okay, we're ready?
I guess.
Hi, and welcome to the CADimensions 3D printing podcast. My name is Adam Fosnot. I'm a 3D printing applications engineer, and every month we get together to have a conversation about technology and 3D printing and all sorts of things that are going on in the world today. At CADimensions, we have a goal to empower engineers everywhere with the best technology possible that then empowers them to impact the world. And we think doing this podcast is just one small way that we can help make that happen. Joining me today is...
I'm Kevin Keefe. I'm in marketing at CADimensions, and I love being on here. I love to talk about this stuff with you guys.
I'm Ken Postal, also a 3D printing application engineer.
I'm Ben. I'm a marketing guy, and I'm only slightly depressed.
I did not expect that to be part of the intro, Ben, but I appreciate it. Yes, we are all...
We're on like day 40 or something of quarantine. And I'm a social type of person.
It's stretching
to
on.
be doing remote podcasts still. I was hoping this would all be over by now. Real quick, before we get going, I have a question for everyone watching. Do you have a 3D printer at home? And if so, what type? Leave a comment below letting us know. And then we will warm our brains up with a thought-provoking question from Ben.
I got a good relevant one for you today.
Okay.
Now, as you know, at least 50% of this podcast group has children. So maybe mostly relevant. But I assume that a lot of our listeners, the ones that do listen anyway, have kids. And we are all stuck at home with our children. And at least in New York, I mean, I don't know how long they've been out of school. It's been a while. All over the country, homeschooling again. Is it time to teach your kids STEM? And off of that, should you buy your children a 3D printer?
It's an interesting question. I feel like I have seen this. So I have an 8-year-old and a 5-year-old, and I have seen from social media and, just other coworkers and colleagues and stuff like that, everybody Zoom chatting. I've met a lot of other coworkers' kids and stuff like that. I have probably seen 4 or 5 people on social media talking about, oh, it's my kid's birthday in quarantine, and instead of a bike, I got him a 3D printer. And I've heard that so many times. It feels like that's a really cool gift. Like, for the first time, I'm thinking about it. Like, my kid's birthday is in June. I'm like, he would really like a 3D printer because then we could make so much cool stuff, and it ties in with STEM curriculum. I think that with so many schools doing remote distance learning, there is a loss of hands-on STEM learning that kids would otherwise get in practical applications in school. Having a home hobby 3D printer to tinker with and for kids to learn on and stuff like that, I think it's a great resource.
I think you should definitely buy them a 3D printer. I would have loved a 3D printer as a kid. I would have just gone nuts with it.
I'm sure.
Back in the day, I would make stuff by using a Dremel to cut plexiglass to make plastic parts for things, and just thinking about having to do that now makes me so upset because 3D printers are so cheap now compared to what they were back when I was growing up. I think it's a great idea. I would recommend getting a kit, though, if you're going to get one. Don't get one that's fully assembled. A lot of the kits now, they go together in 10, 15 minutes. Even.
Like snap together pieces and electronics and stuff.
Right. It's essentially 2 halves of your printer, and you have to put in 4 screws to put it together in a lot of cases. And I feel like you learn more by doing that.
That way if it breaks, you can fix it too, right? If you know how to put it together.
That too. That's helpful.
Yeah.
I mean, plus, as a selfish parent, there's a lot of things that I could probably use a 3D printer for around the house that's all right, well, if he's got one, we've got one, and I can use it as I see fit too. So maybe that's driving some of it.
I secretly want one.
Yeah. You can hear my kids playing above me probably. So
I'm on the fence on this one. I don't think I would until they're middle school or high school. But anything before then, I think it's a waste. But I also value learning to build stuff with your hands and not just with 3D printing. I think that's an important step.
I think there's a lot of things that are toy-fied and gamified where kids can I remember when my son turned 4, we got him, didn't get him Chutes and Ladders or Candyland. It was a babies learn to code. And it was like toddler coding. And it was, just a sequence of things, but it was like the basic tenets of like learning computer programming and stuff. None of it stuck, but still, to your point, Ben, I wish that I had, I was more mechanically minded and did more things with my hands, because my kids would probably do more things with my hands, but they see me tinker with electronics and tinker with like this robotic R2D2 that you can put together that rolls around with the controls that, Wi-Fi to your phone. That kind of stuff gets, the parents excited too.
I got to share something with you. So talk about your kids building stuff. Let me see if I can you guys see that? That's my that
look
is
at
my
that.
son. And we're building model toy cars, and he's sanding the wheels. I probably overprotected him a little bit with the ear pro and the face shield, but he'd be safe to go to like Walmart and that now too.
Yeah.
But
If you're giving him a sander, he'd probably be okay with a basic 3D printer.
Right.
yeah, I really value, and so does my whole family, working with your hands and learning to build stuff on your own. And I think that 3D printers can absolutely do that. Like, you can't, except with a few things, you can't like build something and it's fully assembled, or print something. You have to assemble it yourself, and you have to do slight modifications, whether that's sanding, painting, or just assembly. So I think when my 3-year-old, almost 4-year-old is, I don't know, whatever middle school age is, I have no idea because he's not even in preschool yet.
10, 11, like that
Sure,
area?
around then, I think that's when it would be worth it.
Yeah.
Until then, I'm just going to like email Ken or Adam and be like, hey, can you make this?
Do you guys have... I was going to ask, do we have any resources that we could point people to that are like places to start? And maybe we could include some links and some cards in the video that are maybe websites where, even if I had a home 3D printer, I'm not CAD savvy enough to feed it a model that it could produce and stand on its own. So are there like, outside of Google Sketch and things like that, are there places that you guys know from the hobby community?
Oh, there's so many.
I'm sure.
I know I've got my ideas. I'll let Ken go first. If you were teaching a 5-year-old about 3D printing, what software would you give them?
Softwares, it really depends. Maybe at that age you might not. That might be a little young for doing like not parametric modeling, but just modeling with shapes. I don't know what exact age I would start introducing that. I'd imagine if a kid can go on a computer and like play games on a computer, he can probably handle working with shapes and blocks and putting those together, subtracting from each other to make their own things.
I'm going to sound like every other old parent, but my kid can do everything better on the computer than I can. And
Yeah.
I grew up with it too. Like,
The biggest thing that I would push people to do is I would encourage you to get one, but I've seen a lot of like kid-friendly printers that have come onto the market. They try to create these self-serve ecosystems where you can just pick a model on an app or on a web page and it'll just print. Well, that's nice. You can have it print a bunch of trinkets for you, but the real value and the educational value of a printer is the modeling, the coming up with your own design and making your own idea or thing come to life.
It defeats the purpose.
What?
It defeats the purpose. If you have an app where you can choose like out of 400 different toys and models, what's the point of a 3D printer?
It'd still be fun, and I think you can still teach people about like basic mechanics and like how it's working. Teach them about the machine itself and how it works. But I think the real value is in the making your own models. I mean, I still download stuff and print it just for fun because I like the trinkets at home. But more often than not, I tend to make things I print now.
We still have a flexi dinosaur that you printed for my daughter last year, Ken, that she adores and sits on her dresser every night. And she shows it off to her friends. And then when her little friends come in the house, when they did, it was, oh, cool. Hey, check out my, this awesome 3D printed thing that my, Mr. Ken at my dad's company made. And it's like a conversation starter for her and her little buddies. It's cool.
Mr. Ken. I love it.
But one of the big things, like Adam kind of alluded to, the reason I think it's more practical now than it was when we were in middle school, high school, was the cheapest 3D printer you could get back in 2010, 2012 was $1,500, $2,000. And that's really where they were. Now you can get a fairly reliable machine for about $250.
I think it's competing more with like, I'm going to get my kid a bike, or I'm going to get him an Xbox, or I'm going to get him a Switch, or I'm going to get him a 3D printer. And if you've got kids that are, in that kind of mindset, I think it's great. I think it's cool. Wish I had it when I was a kid.
Yeah. And imagine all the toys you wouldn't have to throw out.
Yeah.
Mr. G.I. Joe breaks his arm. All right, we'll just try to
make him a new one.
Replace it. Yeah.
Make him a new one.
That's a really good point. There are so many breakable and wearable parts on kids' toys. That's a really good point. Even just like
because
bikes and scooters and because where do you get that piece? There's a million cases for that. 3D printers for end of use parts. Yeah.
And it's always some tiny little piece that you like almost could glue back together, but you can't. You have all the measurements right there. It's right in front of you.
Like the baseball tee that I'm still waiting on, Ken.
Yeah.
Kevin, I saw like the rough one that I tried to put together on my bookshelf the other day, and I was like, I wonder how that ever turned out.
The tee?
Yeah.
The backstory to that is, for those who don't know our inner workings of office chatter, my kid smashed his baseball tee with a bat at practice last summer, or last baseball season, and I brought it in to make a new coupling that just, attaches from the part that extends up and down. And it was promising, but I don't think I've actually seen a final product yet. It's been packed away, but it's all right. It's already springtime, even though it's not officially baseball season.
He's got to learn to hit the ball from a pitcher at some point anyway, right? Right.
And he does, but there are lots of practical, Ben will tell you, there are lots of practical hitting drills that adults do on tees or teenagers and high school kids do. So
100%.
One day. But you know what? If I had my own, I wouldn't have had to bug Ken.
I would have just been interesting to see you model it. That's the more challenging part.
And yes, that is the challenging part. And I probably would have gotten frustrated and quit about 20 seconds in. But then who knows? My kid could have taken up the mantle and done it himself.
I have another question for you. I'm going to bring it back in. I'm going to pull it back into 3D printers for kids. What about a pen? Is it like a segue? Yeah.
3D pen?
As like the way...
No?
Don't waste your time. It's not that great. A lot of them are made very cheaply, and they break pretty quickly. It's a lot like a hot glue gun. It is a motorized hot glue gun. I don't really see the appeal of it. I mean, I would put it in the same bucket as other craft activities like 3D pen, popsicle stick building. It's all
having a Cricut
to me.
Vinyl cutter.
Yeah. The only successful thing I've seen people reliably do with a pen, because if you've ever tried to use one, it's borderline impossible because you have to perfectly match its speed, its extrusion speed, and how fast you move your arm. So
easy.
If you're not,
it seems very challenging.
Really hard to do some of those crazy things they show on the advertisements. But I mean, I've seen people that take like just a flat piece of paper and draw a 2D item using the plastic and then peeling it off the paper and having an object for say. Yeah. But it's not really as 3D as a regular printer could get you.
So all the mommy blogs saying that you need a pen, like that's how you get your kids into 3D printing, are just straight out wrong.
I think that's how you discourage people from doing it.
Could be a bad experience for them.
That's interesting.
It could be.
I wouldn't have thought about that.
But I guess my take on it is that it doesn't really teach them about 3D printing because it's more crafty rather than STEM related. Versus a 3D printer, you really get to learn about design and 3D design and machine code and all of these other little nuances that they could apply to
But
like
also
a future career.
Mechanics and engineering and structural integrity and stuff like that, right?
Yeah. And a lot of the cheaper printers have like big Facebook communities and Thingiverse communities where they'll talk shop with each other and they'll post upgrades that you can do to your machines. And so a lot of the cheaper machines can become like learning platforms about 3D printing or about mechanics. If you want them to be that.
So, $1 million question then, Adam. Are we ever closer to the age where, it was once unimaginable that everybody would have a computer at home? Is it not unimaginable now that everybody has a 3D printer at home in the next 25 years?
Well, 25 years is long. Is a long
Okay,
period
10
of
years.
time
10 years
in my
even.
mind. I think we're definitely getting close. I think there's still some usability challenges to using a 3D printer, but I think for people that like making things, it absolutely makes sense to have a 3D printer. Like Ben, it would make sense, in my opinion, for you to have a 3D printer. Just because you like woodworking, you like making things. It's just like another tool at this point. Like, because 3D printers have come down in price to the point where you can go buy a really nice table saw or you can buy a 3D printer with roughly the same amount of money, it's just another tool to have in your shop.
I've
I'm
been
gonna get
thinking
one.
about that, at least for jigs and fixtures. There are so many times where like I have to spend a whole day. It's so funny. We've talked about this before, but when I suck at sharpening knives, especially when I just built it and it's a flat billet, or not billet. It's like it's still like a quarter of an inch thick, 16th, whatever it is. I can't get it sharp, and I've spent days making different fixtures to try to get it sharp, and watched a video on it. It's like, oh yeah, just 3D print this. I was like, oh, that'd be nice. And I think that was even before I was working here. But absolutely, as long as they can deal with like a ton of sawdust, or would I have to like keep it in its own case? I don't know. You tell me. How durable are they?
Printers and sawdust do not get along well.
I didn't think
keep
so.
them very well separated.
Keep it in the kitchen.
I won't
maybe.
keep it in the shop then.
Not in the shop, but in your home office. That's where it goes, and you make the fixture in the office and you take it out to the shop.
Funny story. I got kicked out of my office, so now I'm in my bedroom.
Did you?
Yeah. So I don't think my wife would appreciate having a
printer in the bedroom.
The home bedroom office. But eventually.
Anyway, Kevin, I
Not
feel
a
like
bad
we didn't really get to the heart of your question and what resources would we suggest to kids or families who are getting into 3D printing. And I want to recommend a program that is probably already installed on every one of your computers. It's free. It's easy to use. It's called Microsoft 3D Builder.
It's assuming you don't have a Mac.
Assuming you don't have a Mac. If you have a Mac, it's not on your computer. But for Windows 10 users, it already comes installed on your computer. It's free. It's easy to use. Essentially, you just click and drag shapes. You can resize them. You can add and subtract shapes. So if you want a block with holes in it, you would make some cylinders and position them wherever you want, and then tell it to cut the cylinders out of the blocks. For even doing some minor adjustments to files that you download online, it can be a really nice tool.
Nice. And then you said Thingiverse, and there's other like prefab places where you can get models for things and stuff like that.
Yeah. Thingiverse is definitely the most popular if you're just going to look for a design online. My Mini Factory is another really good one. GrabCAD Community has a whole bunch of 3D models. Those tend to be more engineer focused, whereas if you want just like a lizard, you can go on Thingiverse and find one.
Very cool.
That brings us to our next section, where Kevin enlightens us with a wonderful recent news story about 3D printing.
Adam, thank you so much for bringing me into this, because I thought this was a cool story. I kind of got drawn in, I guess, by the title just because it made a lot of interesting notes about amorphous metal. And from what it sounds like, there is a company that has, or two companies that have partnered together to develop this technology side by side, which they're called a glassy metal, also metallic glass. So materials that have mechanical properties that are like metal, but they're different in a lot of ways. So it sounds like you can manipulate these materials in different ways than you can regular metal. I'm going to try not to read directly from the article, but it sounds like it's very desirable for industries like automotive, manufacturing, medical, and aerospace. When you look at something that is amorphous, it's not necessarily like viscous, but it is low density. But at the same time, it claims to be a higher strength, yield strength 2 times higher than steel, while still being elastic and springy. So I thought that was cool, and I would bring it up to guys who nerd out about 3D printing, because I thought you guys would think that was cool too.
That's awesome. Did you say metallic glass?
Yeah, metallic glass is how they describe it, or a glassy metal. I'm not sure what the difference would be, but it sounds like you're rapidly undercooling metals from a molten state, and that's kind of how you get to this end result of an amorphic metal production process. I just thought it was cool to think, and like in my head, I'm thinking of like a foundry where you have these channels of molten steel coming through, and there's like, an extrusion head or something like that, and that's really what you're producing. I'd love to see, maybe we can find an image for by the time we publish this, like what an example of an amorphous metal would look like. Like, is it cartoonish? Can you smack it with a hammer and it's going to flatten out? Or like, what's going to, you know what I mean?
It actually bounces if you toss it against the ground.
Like flubber.
Bounce right back up. No, that's awesome. It reminds me of, I was reading about a desktop metal patent, actually, that they got, I think, last year about 3D printing with bulk metallic glasses. And apparently, it's not only a really cool, really strong material, but it lends itself really well to 3D printing, where in theory, we wouldn't need any sintering whatsoever, where you could just directly print a part and be able to handle it.
So what is a glassy metal then? Like, does that sound more like it's like a carbon fiber impregnated, like, or fiberglass impregnated plastic? This is glass and metal together, maybe?
I'm not 100% sure. Actually, Ken, you took a powdered metal class locally, didn't you? I know it was a while ago, and now I'm putting you on the spot, but in terms of amorphous metals, I'm not an expert.
Yeah, I'm not a metals expert, but I think I would assume it has more to do with grain direction. And grain direction is usually created by how you cool the metal and how quickly you cool it and how controlled that cooling pattern is. I worked a little bit in castings, and I know when they would do castings, the rate of cooling was absolutely critical to getting the correct grain direction or correct grain growth. So I imagine if they're talking about this from a printing perspective, I frankly don't know which is more. I assume amorphous, if they're talking about it, would be more desirable to extrude. But I have to imagine you'd have to be extruding at an extremely high temperature. So it's still a metal base.
So yeah, the article doesn't go too much behind the science. It does say that the cooling process creates lattices, and defects in the lattice can make metal weaker. Therefore, by rapidly undercooling it, this atomic structures become frozen, and it's more like glass at that point, maybe. But the thing that struck me was, to your point, Adam, like in the future, if you're extruding ready printed and there's no sintering. The properties of this material, they say that their claim is isotropic mechanical properties. So it's strong in every direction, low density and high yield strength, like I said, but then also, biocompatible, high corrosion resistance and magnetic permeability. So it sounds like it would have a lot of applications if it, kind of got off the ground. I just thought it was cool technology.
I'd be interested in understanding how they're printing it, because thinking just in terms of FDM, the weakness that's created compared to a raw block of ABS, just for say, compared to a printed ABS part, is not the material, it's the nature of the process.
Right.
So the layer to layer adhesion is really what's causing that weakness. So if you're extruding this metal, no matter how amorphous that metal is, I think it'd be more dependent on how well you get that metal to congeal layer to layer. I mean, that's why sintering, you get such high, I wouldn't say completely isotropic, but much closer to isotropic, because you're basically borderline melting the layers together.
Right.
Kevin, do you know where they were, off the top of your head, do you know where they were doing this research?
No, it didn't. It didn't say in the article. It said that who the companies were,
Okay.
but not necessarily where that research was being done.
It's probably somewhere in Europe, isn't it? They're really into metal 3D printing over there.
Most likely. I'm just seeing if this got a link, but no, not seeing it.
Yeah, I think right now in today's world, getting big metal 3D printed parts is nearly impossible because of the sintering that occurs, whether it's with DMLS or with a metal injection molding based system, which really seem to be the two big front runners commercially. But if you're printing with amorphous metals, and then I'm making some assumptions here, connecting the metallic glass to some of the patents that I've seen already, with no shrinkage and being just able to directly print the metal, that could open up a lot of avenues.
Sure.
Before we even touch the biocompatibility aspect of it.
It sounds promising. It sounds interesting. I will keep monitoring this, and if we have updates on it, I'll bring it back because I think it's cool.
It is super cool. You are now designated as the amorphous metals expert.
I mean, if you got to be known for something, you got to be known for something. I might as well.
One thing that a lot of people approach us about is about using metal 3D printing to make injection molds, because injection molding has such a reputation for being expensive and time consuming. I think Ken actually wanted to introduce the 3D printing application of the month that has to do with injection mold.
Sure. So yeah, you're leading into metal injection molding, or not metal injection molding, but metal molds.
Can we do it?
Very small ones, yes.
Okay.
Typically, when people are looking at metal molds, you're talking more about production molds, and you're specifically targeting very controlled cooling channels. So if you think about how you manufacture a cooling channel today, if you look at most models, they're just straight cuts. Someone's drilling straight through the mold. So the theory is, if I can make cooling channels that, number one, get very close to my mold, the actual mold, I don't know what it's called, mold
surface? The
surface,
internal cavity?
Internal mold cavity.
I'll buy that.
And I can almost mimic that geometry. I'm not limited by having to cut a straight line. I can get really close and I can almost go right up against that surface. I can cool better and I can make more parts quicker.
Okay.
The topic I kind of wanted to talk a little bit about was actually the prototype injection molding, and even more specifically using the PolyJet technology. We can use FDM for this, but people tend to go towards PolyJet due to the surface finish. Same with like SLA, same reasoning, just the surface quality. But I think there's a lot of surprise to how much you can actually get out of some of these PolyJet molds. I think first thing, it's important to note that these things, when you use the correct materials, can withstand up to about 300 Celsius. So when we're at or below 300 Celsius, we're pretty good.
What are you shooting at? Like, what material would you be shooting at that range?
Yeah, so there's a couple different kinds. You can do elastomers are the best fit. I know probably the most common would be what? Polypropylene is the one I hear most.
Polypropylene does great
Polypropylene is
in
the one that's
polyjet molds.
yeah, I've heard most frequently. I've heard people getting in the hundreds of parts of that. And with all molds in general, a lot of the quantities and the upper limits of what it can do are really going to come down to the geometry. That there's going to be limits on there. But we've done elastomers. We've done some of your standard plastics like ABS and PC ABS. Those tend to be a little bit less than the elastomers. So if elastomers are 100 shot a mold, standard plastics you might be closer to 75 or 50. And then when you start getting to some of the engineering grade materials like glass filled, that's when you're only going to start seeing a couple parts. So really the more wear and tear that material causes on the mold when injecting it, it's not necessarily that you're going to destroy the mold as much as you're going to start losing tolerance. And that's really the reason you can't have hundreds and hundreds of shots of glass filled material.
So
but
you're
outside
pushing melted plastic into the mold, and the mold doesn't melt.
yes, believe it or not.
So
Why?
Because you're still under the actual melting point of the mold.
Okay.
So one of the important things, though, is that when you're using 3D printed molds, and as I said, it's primarily for prototyping, you're going to have to make some changes compared to a traditional mold. You can't just take an immediate design for a steel or aluminum mold and print it out and expect it to work perfectly. Some of the most common things you're going to have to do is you're going to have to increase the draft angle. That's just going to let the part come out of the mold easier because plastic on plastic interface is going to be more resistant than aluminum. The second part is going to be the time. So when you think of injection molding, you think of someone shooting into the mold, opening it, popping the part out, closing it, shooting into the mold, and repeating. You're talking 1 to 2 second cycle times, 3-4 second cycle times. When you're in the prototype stage, though, when using printed molds, typically we're talking maybe a minute per shot because you have to allow the mold to come back down and cool so that it doesn't overheat and melt. It doesn't have that heat resistance that an aluminum would. And then finally, the only other thing that is recommended when using specifically the polyjet molds is they tend to be a little bit smaller. So we're talking like 10 cubic inches of total mass in your mold cavity.
10 cubic inches is pretty big.
It's pretty big, and even in injection molding, it's a good size. But we're not going to create injection molds that are, I don't know, a third of a door panel or big parts.
Ken, you've been talking this whole time about polyjet parts. What's the advantage to making a mold in polyjet versus an FDM mold?
The biggest advantage is surface finish.
Because you're not going to buy in, you're not going to have the lines of the model from the FDM machine.
Correct. Yes. So the layer lines of a polyjet mold are much smaller. We can do pretty much naturally off the machine. You get a glossier surface finish, so it's better for the mold release. I would say the only downside for polyjet relative to FDM is when you're talking about some of those even like really big blow mold or really big, fairly simple geometry molds. Materials like Ultem and PEC, like some of those really high temperature FDM materials, if you can sand down the surface and make it a nice surface, they'll work better. But for most applications, when you don't need those extreme temperatures or big sizes, polyjet's the better way to go because of its fine feature detail.
Good to know.
So what would be the advantage of making a polyjet mold over an aluminum mold?
So there's really a couple key things. When you look at an injection molding shop, there's not a lot of room for prototyping because if you don't have any way to prototype the mold other than maybe if it's simple enough making it out of wood, you have to go and get that mold made out of a CNC. So you have to commit to a metal mold to start. The challenge there is metal molds for injection molding can be very expensive. So ranging anywhere from a few thousand to hundreds of thousands of dollars, depending on their complexity. some of our customers will use the molds to do short runs. So if you only need 10 parts, that's not something your injection mold company would normally even take on because cost per part would be ridiculous. But maybe if they can get 20, 30 parts off a plastic mold and they have equal quality, you can take on those 5 or 10 job orders to get those larger deals in the same package. But more common, I would say, it's really foolproofing your metal mold. So it's a lot more reassuring to spend $800 on a plastic mold and find out that you made a mistake or find out that something's wrong with the mold there before you've committed to the $50,000 6-week lead time metal mold or whatever your lead time is for your company. But knowing that when you go and commit to the very expensive object, you know it'll work right away and there's no questions about that. So you could be spending more in the upfront prototyping process, but you're completely taking away the risk of a full metal mold commitment.
Does it really cost that much for a metal mold? 50,000?
It just depends on the complexity and size. I know the example, I don't know if we can share the picture of the example, but I believe the example part we have, the mold, is only about 4.5 inches long, mildly complex with thin walls. I think that one they quoted for about $50,000.
That is so expensive for a small mold.
It's a lot.
No.
You could buy the new PolyJet printer and just do your own at that cost.
Yes, but at the same time, if I'm going to make 5,000, 10,000 parts, I still want a metal mold. Or if I'm going to be making 5,000, 10,000 parts a month, I want the metal mold. Because if I'm only going to get 200, 300 shots off the plastic one, okay, now I'm spending thousands and thousands. You're going to spend more than that metal mold in just making smaller molds. The other part is when you start to get closer and closer to the limit of your mold, you are going to start seeing it degrade. So if you're in high tolerance situations, I wouldn't be pushing a plastic mold to its limits if you're trying to hold 6, 7, 8 thou.
So 3D printers make plastic parts, and injection molds make plastic parts. How do you know whether you should make an injection mold or just print the parts?
Is that for me?
Yes, Ken. You're the one telling us about injection molds.
That's a good question. I mean, it depends on what you're trying to gain from the part. If you're just trying to test the design of the part and see if you like the form, fit, or function of the part, you might be better off just printing the part itself. But if you're evaluating the mold design or if you're evaluating like the feasibility of the mold, then you might look to actually printing the mold over printing a part.
Gotcha. That makes sense. Related to injection molding, this is our only COVID-related topic for today. But I wanted to end on our 3D printing tip of the month to give some tips on how people can 3D print faster. So we talked about face shields on the last episode of the podcast, and if you're tuned into 3D printing stuff, I'm confident you've seen all of the 3D printing efforts for PPE. And 3D printing is always slower than injection molding. But there are some tips and tricks you can do to be able to print as fast as you can. I think Stefan over at the CNC Kitchen channel did a really cool video talking about his print settings that took a model from, I think, 3 hours down to under an hour. And so by playing with different parameters, you can see a lot better results. So the first one I have is to have the right hardware. A lot of 3D printers in the area where they melt the plastic, called the hot end, it only has about 10 or 20 millimeters of heated area.
Please tell me that's an official term, the hot end.
Yeah,
Is it
it's
really
called
like,
the hot end.
I don't know. Hey, don't touch the hot end. Like, that's what it sounds like.
Heater block. That's the only other name I can think of.
No,
It just sounds
you
like a
know-
labeling for dummies. Like, this is the hot end. Like,
Pretty much, yeah.
I never thought of it that way. I've just always accepted that it was the hot end. But you're right. It's kind of a very simple naming convention.
you're not going to get it wrong. And if you burn yourself, it's your own damn fault at that point. So,
You're gonna learn quick. That's
Yeah.
for sure. But a lot of the stock hot ends on printers only have a very small area for the plastic to melt before it gets pushed out of the nozzle. Compared to our printers that tend to print much faster than the type of stuff that Ken and I have at home, they have a substantially larger melt zone in their hot end. And there are even some upgrades that a lot of different companies make where you can increase that melt zone. And that's going to help you print a lot faster. Increasing your nozzle diameter. The Fortis, for example, has interchangeable tips depending on what layer height you're using. That helps you print faster. Increasing layer height is the second tip that I had. That's a very simple way. Instead of printing in 0.1 millimeter layers, if you're printing in 0.2, it'll print roughly twice as fast because you have less layers to make up your object.
makes sense.
Yeah. The third tip that I have is to add more shells and decrease your infill. And so that can give you kind of an equally as strong part while using less printer movement. So you can end up with a faster print. And when you're adding those shells to your part, you can actually increase the extrusion width. So instead of doing 3 shells, you might only need 2 shells to get the same thickness of plastic on the outside and therefore roughly the same strength of your part.
So I guess one question you had mentioned earlier I wanted to pick at. You had said that injection molding is always faster than 3D printing. So why are we printing all these face shields?
We're printing all the face shields because it takes time to make an injection mold. Like you were talking about, 3 to 6 weeks. And so even companies with injection molding capability in the States, it takes time for them to, stop everything they're doing now, and divert their resources to make a brand new mold, to validate the mold design, and to install it on their injection molding machine and actually start making it. And so 3D printers, because they're able to make anything within reason, right? You can make a variety of different objects without having to make that tooling. They were able to kind of immediately switch over. It's that tooling making time that made 3D printers more responsive than injection molders.
And I think, when did we start printing parts? Was that back like beginning of April or even like slightly before the beginning of
I think
April?
in March we were
It
printing
seems like
parts.
so
Late March, yeah.
I
It
have
seems
no
like
idea.
forever, yeah.
But you've definitely seen less and less of the 3D printing PPE in general, just around social media, because like Adam said, once that tool is made, I mean, you got injection mold companies making
1,000
3,000, 5,000 parts a day. We're making what? Maybe 100, 50 parts a day on our couple machines.
Mm-hmm.
So
Right.
the economics and the scale is just nowhere close. But if you need parts now, that's your trade-off.
Exactly.
Yeah, shout out to all the companies who have a 3D printer in-house and injection molding, and all the staff still there that were able to make all those face shields. In my Facebook feed, Smith & Wesson, I didn't know they had 3D printers, but they went in a little over a week, they said. They started using with injection molding, making 1,000 face shields per day. And that was in just over a week because they had 3D printers to make the prototypes. I'm sure there's tons of other companies out there that did the same thing too.
And I think the important thing with that kind of company too is they have the internal machining capability to make their own molds. A lot of the companies we go to, even the injection mold companies, don't make their own molds. They outsource that to specialized mold makers.
I wonder if that'll change. I mean, the outsourcing now seems that everything's. Well, hold on. Do you mean when they outsource? Are you saying they're going to another country or just another shop?
Not
Just
always.
another
I
shop.
would say the majority. The majority I've talked to usually go to another local facility, a specific machine shop that makes molds.
Okay, so they're not going out of the country at least, but okay.
You
maybe
can
that'll
still
change
get
then.
them, but more that I've talked to tend to get them in the United States.
I've had a different experience. I talk to companies all the time who were like, "Oh, where do you get your molds?" And they're like, "China." It's always China. It takes 10 weeks, but we deal with it because it's so cheap, and they're happy doing that.
Yeah, that's the trade-off. If you've got the time, then find the cheapest option. But if you're on tighter deadlines, then your choices are limited.
Yeah. I would imagine that people will start sourcing things domestically a lot more, given all the supply chain hiccups that people have been experiencing.
Mhm.
Insourcing and relatively local manufacturing, I think, was already kind of a global trend, but we're only going to see that accelerated.
Yeah, if anything, I'd expect simplified supply chains, so you're less dependent, or you're either going to bring stuff in, or you might diversify more to where you're using more suppliers for a particular component. Because you imagine some industries, when a single supplier goes down, your whole operation goes down, and there's nothing you can do.
I think even onto a consumer level, I think our supply chain is going to simplify. And going back to having a 3D printer in your home, whether or not that's going to be the case next year, but I think everyone is going to start trying to at least buy local or be more self-sufficient. That means making your own stuff, so be it. But at least way of the supply chain that we've seen is actually pretty darn fragile. I think in-house is an awesome idea.
I think as more people adjust to the new conditions and changes or whatever it might be, I think one result is more people fixing things instead of buying another one. We have such a throwaway culture that having a 3D printer makes me less likely to just toss the baseball tee and go buy another one. I'll fix it. And if I've got more tools to fix more things like that something maybe I bought from China and I'm not going to get another little widget band to go around this again. All right. And I can make it and I can preserve those and I can make them last longer.
This is a kind of a question that's not super related, but have any of you started trying to just buy made in America whenever possible?
I have.
Yeah.
Not because, sadly, not out of just like an abundance of patriotism, but really because I'm impatient and Amazon takes a long time. I do tend to buy a lot of 3D printer parts to tinker with directly from China.
Did you just say Amazon takes too long?
Yes,
they are.
In the
They've been
current
backed
world,
up. Yeah,
Amazon-
they've prioritized certain
Currently,
things
yes.
over consumer goods, and you can imagine if you're one of the hundreds of thousands of essential workers, you don't necessarily want to pack up Adam's 3D printer parts. You'd rather pack up something that needs to be done.
Boo.
which makes me
Everything's
very
essential.
upset. My hobbies are essential, Kevin.
I don't think I've bought anything outside of groceries.
No?
I don't think I've spent anything in a month. No,
Well,
I haven't.
I can't relate to that. I've
haven't.
been
It's
impulsive.
definitely been limited. I wouldn't say I've cut everything out, but it's definitely a lot less than before.
I bought a new Apple Watch because mine broke, so that did not come from Made in America. But outside of that, no, I don't think I bought anything except beer and groceries.
I just found out that I can have ammunition shipped directly to my house. And what a wonderful thing that was. I look outside in the mail every day. I can see it from my window. I'm like a little kid. Yay, it's here.
I'm that way with printer filament. So I feel that. So real quick, I have two more time-saving tips if you're 3D printing things.
Oh my goodness, I forgot.
Well
Keep going.
sidetracked.
Remember when this was the segment and we just totally derailed? I think
Should
that was
we,
more interesting conversation anyway. But minimize your Z height. So when you're positioning your part, make it as short as you possibly can while allotting for overhangs and all that other stuff. And the last tip is minimize your downtime. And so don't let your 3D printer sit there all night not making anything. That's a waste of time. We saw this with the face shields where people started stacking them and having them be able to break apart afterwards. When we started doing that in the office, we quickly changed pace from doing like 10 or 20 a day to doing like 40 or 50 a day because the printer would keep going all night, and then we'd just toss it in the wash tank, the support would dissolve away, and then you have a whole handful of like 10 or 20 face shields. So making sure your 3D printer isn't being lazy and resting all night is a very important aspect to be 3D printing fast.
Is CADimensions still making face shields?
We aren't. We did it for a long time. Well, a long time. We did it for 3 or 4 weeks. But our sourcing for the transparent plastic that needs to go on the front kind of dried up, and I think we were happy to pass the baton on to a lot of the local companies with injection molding capabilities who could do it way, way faster than we could.
How many did we make?
We did over 1,000. And we gave them to a lot of, I think, friends and family and friends of friends who actually work in hospitals on the front lines. So we put a lot of work in for a few weeks, coming in like nights and weekends to make sure the machines were okay. But it was really rewarding seeing a lot of what Andy shared with us at our company meeting. The audience knows exactly about this. But seeing all of like his screenshots of texts and Facebook conversations of people who really benefit from it.
Yeah, nice job. Did you
Thanks,
give one
man.
to your wife?
I did not.
Wow.
She's one step removed from the front lines, thankfully.
Oh, good.
Right.
Is that it, guys?
That's it. Thank you, audience, for watching this very special socially distanced podcast. If you enjoyed watching today, make sure to leave a comment with hopefully some words of encouragement. I know things are difficult for everyone right now. And tell us what your favorite segment was. I know when we switched to the segmented format, we had a lot of ideas, so getting your feedback on which segment is your favorite would be awesome as we try to plan for the future of the podcast. Make sure to subscribe to our channel so that you don't miss when we post next month's podcast. Thank you so much for watching, and we will see you next time.
See everybody.